So hey guys, welcome to my channel, and without wasting any time we are going to start our video. Here given that derive an expression for electric field intensity. What? Electric field intensity on axial line at a point situated at a distance from electric dipole. So the question which is given is most important for Bihar board especially, and in any board like CBSE, state boards. It is very important, and as we all know, our Bihar board exams are going to held from 1st of February, so we should do this question. So without wasting any time, let's get started. So here we are given that there is a electric dipole. Okay, sir. So here we are given that there is a electric dipole, and electric dipole, that we all know that electric dipole is the system of two charges of equal magnitude and opposite charge, like plus q and minus q, and are separated from small distance by small distance. Okay, so let's get started. We are to assume something, we are leaving these lines and starting from here. We are given that there is an electric dipole, so let's say this is minus and this is plus. This is situated from small distance. Okay, sir, small distance, right? And the center of this dipole, let's say O. And as we all know, we are given that we have to derive on axial position. So let's say on axial position we have this point M, and we have to derive electric field intensity on point M. Okay, so now let us assume that from center of dipole to point M, distance is R, let's say. Okay, sir. And this is the center. So if this is D, then this is also my D, because this is center of dipole. Okay, sir. Now let's say, and as we all know that electric field due to plus 1, let's say this is minus q, and let's say this is my first charge. Let's say this is plus q and this is second charge. Okay, so electric field due to plus 1 will be more than minus 1, because this is separated by small distance and this is large distance, and we all know electric field is inversely proportional to r, like distance. The electric field due to 1 will be more than electric field due to 2. Electric field due to 2 will be more than electric field due to 1. Let's say this is E2, electric field due to second charge, and let's say this is E1, electric field due to first charge. And as we all know that direction of electric dipole moment is from minus to plus, so this is the direction of, let's say, electric dipole moment P. Okay, now whatever we have assumed, we should write that here. Okay, so we have you should also write like this in your exams, so that you can get 5 out of 5 marks, and trust me, you will get that. So we have assumed that let an electric dipole having charge minus q and plus q, having charge minus q and plus q, let's say. Okay, and separation between them d plus d, 2d, d plus d, 2d, and separation between them is 2d, let's say. Okay, so whatever we have to derive, so we have to derive okay, we have to derive electric field intensity due to dipole at distance r from center of dipole, right? Electric field intensity due to dipole at point M from at distance r from center of dipole. We can write this. We have to derive electric field due to dipole at distance r. You should write like this, okay? Distance r from, I don't think you are getting bored. I think you are also enjoying my video. From center of dipole on axial position, okay? Center of dipole on axial position. I know my handwriting is not so good, so mind it. You have to, okay, so read this firstly, okay? I hope you have written this. Now let's say this is O, point O. Yeah, we have assumed that this is point O, center of dipole, okay? Now what I have assumed? E2 and E1. We also have assumed na electric field due to 2 is E2 and electric field due to 1 is E1. We should write this also to get 5 by 5. We have also assumed, look here, that electric field due to second charge is E2 and electric field due to first charge is E1. So we should write this so that we can get 5 out of 5 marks, and both will not cut my marks anywhere, okay? Now let okay, I think you guys are getting bored, but don't worry, overall my video is so amazing. Let electric field due to minus q is E1 and due to plus q is E2, okay? Okay, sir. We know that direction of E1 and E2 is opposite. Since direction of E1 and E2 is opposite, right? Right, sir. What? Right, sir. Never mind. Therefore, E net, as we know, this is vector addition, that's why E net is equals to E2 minus E1, because this is extra in magnitude and this is less in magnitude. In vector addition, we subtract, if they are in opposite direction, we subtract extra magnitude to less magnitude so that we can get the net electric field, okay? Okay, by vector addition. Hope you understood this. Now what we should find to get E net on M? We should find firstly E2 and then E1, or we can say firstly E2 or E1. Okay, now as we know, electric field due to charge is kq by r square. I know that kq by r square, let's say x square, okay. So we can say that this is kq by r square. Electric field due to second, yeah, this is electric field due to second. This is our distance, okay? And so this is r and this is t. If we subtract this, let's say r and this is d, okay? To get this distance, we should subtract from r minus t, right? kq upon r minus t का whole square, okay? Now we should get E1. E1 equals to kq upon x square, right? It can be written as kq, right, upon x square. This distance, this is d and this is r, so r plus d. Hope you understood. This is d, and this is r. R plus d equals to from minus q to m, right? R plus d whole square, right? Now we want to know that what will be E net. Now Net equals to, from here equation 1, net equals to E2 minus E1. We are given that E2 kq upon r minus t whole square minus kq upon r plus t whole square. First of all, you guys please pause the video to note it down. Once more, please pause the video to note it down. Okay, what we have done, students, here, net equals to E2 minus E1. We wrote that kq by r minus t square minus kq by r plus t whole to the power whole square. Kq I took the common, into 1 by r minus t whole square minus 1 by r plus t whole square. Okay, so we took the LCM again and make the LCM. Now we have r plus d whole square, r square plus d square plus 2rd minus a square plus 2ab minus b square. So a square minus d square plus 2rd, okay, upon a square, a plus b into a minus b. What is that? A plus b into a minus b, a square minus b square. So r square minus d square to the power whole square, right? Right, sir. Right. So now we have what? We have nothing. We have this kq into r square plus d square, and from here you can see that plus 2rd minus r square minus plus d square, right? 1 minute. A minus b whole square. What is a minus b whole square? A square plus b square minus 2ab. It will be plus and it will be minus. Sorry students for that. Minus r square minus d square, okay, and plus 2rd, right, upon r square minus d square to the power whole square. R square d square 2rd 4rd. We can say that kq into 4rd upon r square minus d square to the power whole square, right, sir. What? Right, sir. Okay, now kq into 4rd upon r square minus d square to the power whole square, right? So it can be written as, to get, as we know that p equals to q into 2d, so we can do k q into 2d, okay, sorry, q into 2d into r upon r square minus d square to the power whole square. So from here we need E net equals to 1 minute students, 1 minute. Yeah, E net equals to 2 kp r upon r square minus d square to the power whole square, okay. And we all know that electric dipole is defined for short distance. So you can see here that, what you can see here, this t will be much more smaller than this r, right? This t will be much more smaller than this r. So we are going to write this, okay. So we know that since electric dipole is defined for short distance, okay, separation, right, short distance separation, right, therefore r is much more greater than d, okay. Now much more greater than d, so this will tend to 0, okay. So we have E net equals to 2 kp upon what? 2 kpr upon 1 minute. This will not tends to 0. 1 minute. This will tends to 0, na? This is much smaller, so this will tends to 0, this will not. Sorry for inconvenience, I thought this was my r. Okay, 2 kpr upon r to the power 4. Yeah, 3r, it can be written as 2 kpr upon r cube. Okay, so learn it. This is to learn. Okay, now and mind students, axial is along electric dipole moment p, because electric dipole moment go from minus to plus direction, as we all know, and our electric field also going from minus to plus direction. That's why axial is along electric dipole moment p. Okay, now what's this? Pause the video and note it down. Pause the video and note it down. And second one, students, pause the video to note it down.